Okay, so we're on to the last example, which is wiring a fog lamp. It's quite a long example, so please bear with me. Okay, CEO bought a new 12-volt bulb for the headlight on his motorbike. He tests the bulb by connecting it in series with a 12-volt battery. So that there, that there is your supply voltage, and an ammeter is shown in the diagram. The current through the ammeter is 4.6 amps. So that's all because the lamp is the only thing in the circuit. There's going to be 4.6 amps of current going through that lamp as well. And you have to calculate the resistance of the lamp. Okay, so we know that V equals IR. So R is going to be V over I. Now, because the supply voltage, all of the supply voltage goes through the lamp, we can use 12 over the 4.6, and when you calculate that, you get 2.6 ohms to two significant figures. Okay. The part B show that the power output of the bulb is 55 watts. So power is current times voltage. So power is your 4.6 times a voltage of 12, which is 55.2. So that's showing you that the power is 55 watts. Now, just so that you get used to doing this in the exam, if the question says show, it means write a formula and substitute in some numbers, and your answer has got to be 55. You can't use the 55 during the question. Okay. Part C, calculate the amount of energy supplied by the battery when the bulb is turned on for 2 minutes. Now, I read that question, and the first thing I think is I can't use minutes because that's not a standard international unit. So I need to turn my 2 minutes into seconds. Now, I know that one of the formula for power is change in energy over change in time. So if I want an amount of energy, it's going to be power times time. So that is your 55.2 times your 120. And when you work that out on your calculator, you'll get 6,624 joules. Okay? Or if we're going to be really proper, it would be 6,600 joules to two significant figures. I don't think they'll be too strict about that in the end of your exam. So that's A, B, and C done. Hopefully you've managed to keep up with that. So now the circuit becomes slightly different, and we've now got a headlight and a tail light, and they are in parallel. Okay, so before we even start, I think to myself, okay, I know that the voltage through here is going to be 12, and the voltage through here is going to be 12 because voltage is the same in a parallel circuit. And I also know that the headlight, which is the same one as above, has a resistance of 2.6 ohms, and I know that the tail light has a power rating of 18 watts because I'm told that here. So what do we need to do? By first calculating the current through the tail light, calculate the resistance of the tail light. Okay, so I know that power is equal to current times voltage. So therefore current is going to be power divided by voltage. So that's 18 divided by 12. And that gives me 1.5 amps. So that's the current through the tail light, but that's not the end of the question because we now have to calculate the resistance of the tail light. So resistance, I'm going to call it R tail. is equal to the voltage going across the tail light and the current going through the tail light. So that is 12 divided by 1.5. And that is 8, gives us 8 ohms. So we've calculated the current first and then the resistance. Okay, now we've got another circuit again. So we've got a 12 volt supply voltage. So we know again that we're going to have 12 volts going through this branch and 12 volts going through this branch. The difficulty this time is that we've got 2 resistors in branch AB. So the 12 volts get split between the 2, whereas all 12 volts will be used by the tail light here. Just going to calculate the resistance of the tail light. So we know that resistance here is 8 ohms because we've just worked that out. Okay, it means we can work out the current through there. So part E is an explain question, so that immediately tells you that it's more than achieved, probably merit. Okay, so we're talking about brightness. So whenever you're asked about brightness, the first thing you need to think about is brightness is directly related to power, okay? And power is current times voltage. So if we know that the fog lamp is not getting all of the 12 volts, then if voltage reduces less than 12, then the power is going to reduce. And that's the reason that the fog lamp is dimmer than it would be if the headlight wasn't there. So what are we going to say? So the first thing I'm going to say is the headlight and fog lamp are connected in series, and therefore share the 12 volts of energy dissipated. Dissipated is we'll use that word a lot in year 12. So that, sorry about my writing, that says dissipated across branch AB. So I've got those letters from there. So the headlight and the fog lamp are connected in series and therefore share the 12 volts of energy dissipated across branch AB. The fog lamp does not receive all 12 volts, so will therefore not be as bright. Okay, where did we get to? Part F. The working resistance of the headlight is 1.3 ohms and that of the fog lamp is 1.8 ohms. Show that the current through branch AB of the circuit is 3.9 amps. Okay, so we know the voltage through AB is 12. We know that the resistance of AB is equal to 1.3 plus 1.8 because they're in series, so that's 3.1 ohms. So the current through AB is the voltage divided by the resistance, which is 12 divided by 3.1, which is going to give us 3.87 amps, or 3.9 amps to 2 significant figures. Okay, hopefully you followed me on that one. You notice that I'm using V equals IR and P equals IV a lot. But each time I'm putting a little symbol down the bottom so I can see for myself what I'm working out. Find the voltage across the fog lamp. So we know that in series, current is always the same. So the current going through the fog lamp is 3.87 amps. The resistance of the fog lamp is 1.8 ohms. So the voltage going through the fog lamp is the current times the resistance, so 3.87 times 1.8, which gives us 6.966, or 7 volts to 2 significant figures. That's the voltage through the fog light. So we know then that the voltage through the headlight must be 5 volts. Okay. All right, last couple. The power output of the tail light is 18 watts. Calculate the combined value of the current through both branches and use this to find the total effective resistance of the circuit. So we're looking for R total. Okay, so the first thing I'm going to do is work out the current through the tail lamp. Okay, so the power of the tail lamp is equal to current going through it times the voltage used by it. That's correct. So sorry, I've lost my train of thought there for a minute. So I is the power over the voltage, which is 18 divided by 12. Tail lamp, that's the one at the bottom. Oh, that's why I'm confused. 18 divided by 12, which is 1.5 amps. So that's the current through the bottom loop. And we've already worked out our current through the top loop because we worked it out back here, 3.87 amps. So the circuit current, or the current through the whole circuit, is 1.5 plus the 3.87, which gives us 5.37 amps. And then the total resistance of the circuit, so I'm running out of space here, is supply voltage, which is your 12, divided by the circuit current, which is 12 divided by 5.37, which comes out at 2.2 ohms to 2 significant figures. Hope that makes sense. That's quite a lot of work in there. That would be getting up towards an excellence question. Okay. So Sio's uncle now connects all the 3 bulbs in parallel with the 12-volt battery. So now we've got power pack 1, 2, 3. Okay, that's all in parallel. Oh, I was just trying to make that go, but I'm not very good at this iPad thing. Hopefully, there we go, that's done that. Okay, so what do we got to do? The power output of the fog lamp. So the voltage of the, let's get a pen. The voltage of the fog lamp. The voltage of the fog lamp is 12. The resistance is 3.2. So from that we can work out the current. 12 divided by 3.2 is 3.75 amps. They are all for the fog lamp. Sorry, I didn't use my little signs. So the power of the fog lamp is equal to the current through the fog lamp times the voltage through the fog lamp. So that is 3.75 times 12, which gives us 45 watts. two significant figures. Okay, hope you've managed to follow that. That was a lot of calculating and not too much explaining. So the next example I might find one with lots of explaining in. Thanks, girls.